In this video, I'll manually set up an overlay between open vSwitch virtual switches using VXLAN as the tunneling protocol. If you are brand new to overlay networks in the cloud, I suggest first watching my Introduction to Cloud Overlay Networks video. Also, if you are new to open vSwitch and OpenFlow, I recommend watching my introductory videos on those topics, as I won't cover those basics here. Here I'll show the configuration of VXLAN tunnel ports in OVS. Then I'll manually add OpenFlow flow entries to make use of the VXLAN tunnel. I'll demonstrate the tunnel in action, showing connectivity for 2 tenants over the tunnel. Overview. Let's jump right in. For this lab, I have everything emulated on a single desktop. There are 2 VMs running Mininet, which will represent physical servers, and a third VM routing between the Mininet VMs. I don't want to focus on the emulation though, so we can focus on the OVS tunneling. This is the network topology being emulated. There are 2 physical servers and 2 different subnets. Server 1 has IP address 192.168.1.10. Server 2 has IP address 192.168.2.20. Since they are in different subnets, there is a router in between them for IP reachability. Server 1 and Server 2 are both using Open vSwitch for networking between VMs. Server 1 and Server 2 are hosting 2 tenants. There is a red tenant and a blue tenant. The red tenant has VMs Red 1 and Red 2. Red 1 is using IP 10.0.0.1. Red 2 is using 10.0.0.2. Then we have the blue tenant with VMs Blue 1 and Blue 2. This tenant is also using IP addresses 10.0.0.1 and .2. These tenants are even using overlapping MAC addresses between them. I'll set up a VXLAN tunnel and use tunnel IDs to logically separate tunnel traffic between red and blue. The VXLAN tunnel will also provide layer 2 connectivity despite there being a router between server 1 and server 2. Finally, the tunnel will provide a logical separation from the physical underlay network, which has no knowledge of the tenant IP addressing in use. So let's make this work. As I said earlier, this is all emulated on my desktop, so I'm using Mininet to represent the physical servers. This Mininet VM represents server 1. I'll launch a custom topology I built previously. With the dump command, I can see an OVS instance S1, as well as the 2 tenant VMs Red 1 and Blue 1. With the Red 1 IP add, we can see Red 1's IP is 10.0.0.1 and also its MAC address. Blue 1 IP add shows that this VM is also using IP address 10.0.0.1 and even the same MAC as Red 1. Over here is another Mininet VM representing server 2. And I'll launch my custom topology here as well. And we'll see that Red 2 has VMs Red 2 and Blue 2. Setting up the tunnel. Back on server 1 here, first we'll turn up the tunnel between the 2 vSwitches. So here on server 1, I'll paste in a command and then I'll explain it. So this is an OVS vsctl command, which means I'm making a change to the OVS DB, the configuration database for Open vSwitch. It's the add port command. This is adding a port named VTEP. VTEP is just a name here. It can be any name you want. This port VTEP is being added to vSwitch S1. -- set interface VTEP type equals VXLAN. This is saying the tunneling type will be VXLAN. If we wanted this to be a GRE tunnel, we would simply change this to type equals GRE. /remote IP equals 192.168.2.20. This is the IP address of the other end of the tunnel, which is over on server 2. /key equals flow. With VXLAN, we want to use VNIs, or VXLAN network identifiers, to identify and logically separate tenant traffic. With this key equals flow, no particular VNI number is being specified yet. You could specify an actual VNI here, but then you'd have to add a tunnel port for every single unique VNI you need. Key equals flow provides a kind of overloading of the tunnel command, so we don't have to do that. We will see this in a moment. Finally, there is ofport_request equals 10. This is a really helpful option where we are specifying that we want to use OpenFlow port 10 for this port named VTEP. If we don't do this, we don't know exactly what OpenFlow port number we will end up with, which would be bad for our OpenFlow flow entries later. OVS vsctl show displays the tunnel port and interface VTEP, that is VXLAN, and the options set just as we requested. OVS OFCTL show S1 confirms that the port named VTEP is mapped to OpenFlow port 10 as requested. Now I'll paste in almost the same command on the other side on server 2. The only difference actually is the remote IP part. Now it's 192.168.1.10 to point back to server 1. Flow entries. So the tunnel is configured. Now let's add flow entries to direct traffic for the red and blue tenants. I have a file ready to go called flows.txt with all the flow entries that are needed. So I'll load that up and then explain what I have and why. Back to server 1. OVS OFCTL add flows s1 flows.txt. That loads up these flows. Here is server 2 in the same command, OVS OFCTL add flows s2 flows.txt. Let's look at this file flows.txt on server 1 to see what was just added. I wanted to make this relatively simple, so there are really just two functions happening here. Table 0 is used to tag flows with the VXLAN VNI. Table 1 is used to forward packets. First, the table 0 flow entries. The first flow entry says for any traffic coming in OpenFlow port 1, that traffic will get a tunnel ID of 100. OpenFlow port 1 is where the VM red 1 is connected. Tun_ID maps to the VNI that will be used over the tunnel. Then this flow entry says to move on to flow table 1. In other words, all traffic from VM red 1, assign it Tun ID 100 and move on. The next line is similar and says any traffic in port 2, which is blue 1, assign Tun ID 200, that'll correspond to VNI 200. Finally, there is a default action to go to table 1. Table 1 is used for forwarding packets. So if the Tun ID is 100, which was reserved for the red tenant, and the destination MAC is this, that's traffic for VM red 1, so send it out OpenFlow port 1. The next roll looks almost exactly the same, but is matching on Tun ID 200, which is the VNI for the blue tenant. So send traffic to this MAC to OpenFlow port 2. Even though VMs red 1 and blue 1 have the same MAC, flows are distinguished by the VXLAN tag. The next two lines are for traffic destined to red 2 and blue 2, which sit over on the other physical server, server 2. Those packets are sent out OpenFlow port 10. Port 10 is the tunnel port we requested earlier. Next, there are rules to handle ARP. These are directing where to send ARP requests. 10.0.0.1 IPs are local VMs, and depending on the Tun ID tag, ARP requests are sent to either red 1 or blue 1. And again, there are rules for red 2 and blue 2. ARP requests for those systems go over the tunnel port 10. Finally, there is an explicit default drop rule. These are the flows over on server 2. They have the same strategy as what was just shown for server 1, except traffic for red 2 and blue 2 is local traffic, and red 1 and blue 1 goes back through the tunnel to server 1. Verifying the results. Back to server 1. Here I'm testing from the mininet prompt again, red 1 ping 10.0.0.2. This works, so red 1 can ping that IP, which we expect to be red 2. Let's try for the blue tenant, so blue 1 ping 10.0.0.2. That works. But in this case, even though the destination IP is the same, 10.0.0.2, it's blue 2 that's being pinged. Let's verify the pings are going to the VMs we expect and we're not being deceived by the same destination IP address of 10.0.0.2. Over on server 2, I'll disable Blue2's ETH0 interface, so Blue2 IP link set device Blue2-ETH0, so actually the name of the interface is Blue2-ETH0, down. So Blue2 has no network connectivity now. And back to server 1 one last time, red 1 ping 10.0.0.2. This still works as expected because we didn't do anything to red 2. And we'll try the blue tenant, so we'll do blue 1 ping 10.0.0.2. And it looks like this is not going to work. Yeah, we're getting a destination host unreachable. So this is the result we expected. This is failing now because Blue2 was disconnected. That's it for this video on VXLAN overlay networks with Open vSwitch. I hope you found this video helpful. If you'd like to see more, please subscribe to this channel. As always, you can find me on LinkedIn at linkedin.com/in/David Mahler. Thanks so much for those who already added me there and said hello. In the video description, I included key reference links that were used for this video. Of course, openvswitch.org and the openvswitch.org mailing list, Brent Salisbury's excellent network static blog, specifically the post setting up overlays on OpenVSwitch, the randomsecurityguy.com by Derek Chamorro, specifically the VXLAN post, the IETF VXLAN draft, and the IETF Network Virtualization Overlays Working Group, or NVO3.